Good morning and welcome to everybody. I think we can start now, and everyone that is coming after will then join us during the webinar. All right, my name is Lindiwe. I'm the marketing manager for Sub-Saharan Africa, and on the call I have Theo Liao, who is our technical engineer for our branch in Europe at our headquarters in Europe, Germany. And I also have Jonas, who is our technical engineer for Solar Academy, who is based in China. So I'll just do a brief introduction on both our trainers for today who will be doing our webinar. Jonas is his professional field. He is a PV system design, residential and CNI system solution, and also specializes in residential and CNI inverters. And Theo is our technical engineer for EMEA, which is in Europe. He specializes in PV system designs and engineering support for grid light inverters. So today they will be taking us through our webinar. If you have any questions, please post them on our Q&A at the end, and they will answer for you. I would like to introduce Jonas. You can start. Thank you.
Sorry, there's some problem with my computer, so I will start now.
Not a problem. Thank you, Jonas. You may take over.
Okay, yeah. And let me share my screen now. Okay, so could you see my screen, everyone? Yep. Okay, so, okay, nice, thank you. So now I'll start. So today I will introduce you about the safety products, topics for CNI and utility scale. As we know, the safety is one, we could say the safety is the most important topic for the PV system, because it is not only related to the property of the owner of the PV plants, but also related to the human safety. So that's the reason why we want to introduce you about the safety features of the GoodWe inverter. So I've introduced this topic from several points. So at first, of course, I've introduced the GoodWe CNI and utility scale products. And then I think the most of people pay much attention to is about the fire protection. And then I've introduced something about the NS protection, which is a regulation in Germany. And my colleague Theo will introduce something about the protection against surge and protection of the data. So let's start. At first, let me introduce our commercial and industrial products. We have three series of products, including HD series, MT series, and SMT series. HD series was released in recent 2 years, which ranges from 73 to 136 kilowatts and has 12 MPPTs. That means this product can adapt to the multi-angle application scenario, like the mounting area. And in the normal condition, the inverter is used in the normal grid with 400 for on AC side. But in some region, just like in Belgium, they use the low voltage grid, like 230 volt on AC side. And in some region, some big CNI project, they also use 500 volt AC side. For all this application scenario, we have this version of HD series and MD series. And they all have, and SMT series, they all have the low voltage version and the high voltage version of these products. So apart from these features, all these inverters are optional also for the AFCI. It is also called the ArcForce circuit interrupter, which can protect the inverter from the ArcForce. And they also have a very good heat dissipation performance, so which could protect the inverter from the over temperature. And for utility scale, here it is also called HT. So this is one of the most products in our company. So with 1,500 for DC input and power of 225 and 250 kilowatts. So this inverter is compatible with the high power modules, which is very popular in these 2 years. Just like the China Power, they have now the 210 millimeter PV module, and Longji, they have their representative, the 182 millimeter PV module, which all this PV module has a very high power density and a very high output current. So which is also a challenge now for our inverter manufacturer. But now our HD series is completely compatible with this high power module. And apart from the inverter itself, we also provide the complete utility scale solution. So just like we provide the second generation power line communication and IV curve diagnosis, and also the reactive power supply during the night. All these features could save a lot of operation and maintenance cost for the owner of the PV plant. So that's all the products for the CNI and utility scale. And now let's get in the safety features of our products. So I will see the protection in the PV system. The first topic we are about the fire. So according to the data from Fraunhofer ISE, to date, 0.006% of all PV plants have caused a fire, resulting in serious damage. And in recent 20 years, 350 solar systems caught fire, with the PV system being at fault in 120 of these cases. And in 75 cases, the damage was very severe. And in 10 cases, the entire building was burned to the ground. So from this, we could see the fire issue in PV system is very severe. So what's the reason of the fire in PV system? So there's so many. So here I will talk about the main three causes of fire in PV system. So the ArcForce, the over temperature, and the leakage current. The ArcForce in the PV system is always caused by the damaged wire or the improper installation of the terminal. So the very high voltage on the is very high, will generate the ArcForce during in the air. In this time, the AFCI in the inverter, which is also called the ArcForce circuit interrupter, will detect this ArcForce and send the signal to the inverter, and will disconnect, will shut down in less than 0.5 seconds, which is much better than the standard of UL and IEC standard, which defines the disconnect time of 2.5 seconds. So apart from this disconnect time, the GoodWe FCI solution also has a very high accuracy, which reaches, we could say 100% with a very low fault alarm and missed alarm. You know, when there are many missed alarm or fault alarm, it will cause a lot of external costs for the operation and maintenance. And this function, the FCI function, it is available for all our CNI and utility scale products, including SMT, MT, and HT series. Another very important reason for the fire in the PV system is the overheat. So to avoid this issue, the GoodWe inverter has a very good heat dissipation path. For HT series, the path is from down to up. And for HT 1500 volts, it has 6 very powerful AMB external fans and 3 internal fans. So, and for other series like HT 1140, it has 5 external fans. So how we can see the heat dissipation is very good. We could see the picture on the right side. So this is a temperature derating curve of HT 100 kilowatts. So, you know, the greater the power, the greater the power is, the more heat the inverter will generate. So always when the temperature inside of the inverter is very high, the inverter will start derating. I can see for this 100 kilowatt HT, it start derating from 45 degree, while our SMT and MT series derates from 50 degree, which is much better than other brands on the market. And the last reason for the fire in the PV system, because it's also very main cause, it's the leakage current. According to the research, if the leakage current exceeds 300 milliampere, it will cause ignite the fire hazard of the deposits and isolation. So how to avoid this issue is to install an external RCD. It's also called a residual current device that with rated current of 300 milliampere to protect this hazard. There are also some standards that define this 300 milliampere RCD, like IEC 60364 and 42. So in some installations, for example, the permanently made of flammable construction materials in a bar or in wooden cabins, so which is very normal in Netherlands and in Germany. And in some installations that contains irreplaceable goods of great value. So all these locations need RCD with 300 milliampere. So what is this? What is RCD? Takes the challenge for the inverter. The larger the PV system, the greater the leakage current could be, the potential leakage current. So if you could find, if you install no more inverter over 30 kilowatt, take an example of if you install an inverter with 50 kilowatts and you install 300 milliampere RCD on the AC side, then you will find the RCD will trick frequently. But with GoodWe solution, you will not have this problem. Because we find that in, for example, in Netherlands and Germany, there are so many bars and wooden cabins. So we realize this problem. And based on this situation, we optimize our SVPWM modulation to reduce the leakage current. That means under the same conditions, with GoodWe solution, with GoodWe inverters, the PV system on the AC side or for whole PV system, the leakage current will be less than the other normal inverters, which also the cause less fire. Let's see, and after less testing and verification, GoodWe SMT series and MT series ranges from 36 kilowatt to 60 kilowatt are all compatible with this type A and type B RCDs with a rated residual current of 300 milliampere. Yeah. And the last topic I want to talk about for the protection is the NS protection. So we could say this is also called the network and system protection. In German, it is called the NR-Schutz. So let's talk about it. So actually, this is not applied for all European countries. It's only applied in Germany. So this requirement is from VDE ARM 4105 2018 and 11. So it is required that for our PV system between 35 kilowatt and 135 kilowatt, there is a protection between the PV system and the grid. So for this, there are two devices that are needed. So the first one is the protection device monitor that between the PV system and the grid that can monitor the voltage and frequency of the grid. If there's any abnormal, then the interface switch will disconnect the PV system and the grid within 100 milliseconds. So here is the detailed requirement of the standard. So to realize this function, I will say the GoodWe has the advantage compared to other brands. So at first, it has inbuilt interface switch, which can switch off the devices within 100 milliseconds. For the MT series and for the SMT series and the MT series ranges from 25 kilowatt to 80 kilowatt. For other brands, I will say there are some brands that to realize this function, they need an external interface switch that would cost about 200 euro to 500 euro. So with GoodWe solution, in this situation, we could save about 200 to 500 euro. So another advantage of this, actually the S protection is related to the remote shutdown. So this is related to the human safe. You could disconnect the inverter in a remote way. Yeah. And they are both the protection against surge and another topic. Theo, my colleague Theo will take over the presentation. Thank you.
Thank you, Jonas. I will now share the presentation again. Second. Okay. So do you see the screen now? Only the presentation?
Yes, you can.
Yeah. Okay, great. So thank you, Jonas, for showing us the different solutions, how you can protect your system against fire and also the specific requirements for Germany. Now I will shortly talk about how you can protect your system against power surges, and then also how you can protect your GoodWe data. So firstly, about the power surges. Let's see. So first, why do we need surge protection, and what is a power surge? So a power surge is a sudden increase in voltage, and this can occur due to operational or grid operational happening. And so, for example, if you have a very large load connected to your system and this load suddenly disconnects from your system, then you will have a very rapid increase in the voltage. So you will have a voltage spike in your system. A voltage spike can also occur due to nearby lightning strikes, and lightning strikes doesn't need to hit the device directly to cause voltage surge. So if the lightning hits, for example, nearby AC power lines, this will also produce a very large voltage spike in the power lines, and this can then reproduce to the AC side of the inverter. It could also hit the ground, for example, near the DC cables, and due to its magnetic field, this would then induce a surge in the DC lines as well. And the installations on buildings often also has a lightning protection system with a lightning rod that captures and diverts the lightning. But even here, you can get an induced current in your cables. And this, of course, depends on the distance between the cables and where the lightning hits, or the lightning path. And PV plants are very prone to lightning strikes, actually. So the characteristics of the PV plants is sort of the cause of this. They are usually installed on very, very large open areas or on top of buildings. And moreover, they often have a very high DC system voltage and operate close to their open voltage limit of the system. And this makes them very sensitive to power surges, and to protect the loads and installation, it's necessary to install a proper SPD, or a surge protection device. If not, a power surge could then potentially not only damage the inverter, but also the whole installation. So shortly, what is a SPD? An SPD is a surge protection device, and this is a protective device for limiting the voltage on your sensitive equipment. So what it does is that it diverts the surges from the sensitive equipment to somewhere else. Moreover, there are also different types of SPDs. So you have, for example, type 1 SPD, you have type 2 and type 3. So type 1 is then for direct lightning strikes, and direct lightning strike, that doesn't mean that the lightning strikes directly on the inverter or on the module, but it does mean that there is an installed lightning protection system, often with a lightning rod that capture the lightning. And this counts as a direct lightning strikes, and then this system then diverts or redirects the lightning into the ground. But then this also causes a power surge on the nearby power lines. Type 1 is often then installed if you have this lightning protection system, and it's also often installed on the AC side. It can be installed on the DC side, but this is usually a bit more costly. And there are also other ways of avoiding to install the SPD on the DC side. Moreover, the SPD is usually installed with, or the type 1 SPD is usually installed together with the type 2, so it's very rare that you only have the type 1 SPD. The type 2 SPD is for indirect lightning strikes, and this is sort of the main protection system for low voltage electrical installations. So this is sort of the main SPD type. Then we also have SPD type 3, which is sort of the weakest SPD type, and it has a very low discharge rate capacity, and it should normally only be installed together with type 2. Usually in your system, you have many different types of SPD on different locations to protect the whole system. And type 3 is usually then installed to protect, for example, communication lines or other sensitive loads. And the type of SPD that's necessary depends on the installation location and the system design. So in case it is installed in a lightning intense area, for example, it would be necessary to have an SPD that could protect it from direct lightning strikes. And the distance between the PV modules and the inverter also plays a role in this case. So if the distance is large, then it can also be necessary to have an additional SPD on the PV system side and not only the inverter side. Usually when doing larger installations, it's necessary to do a risk analysis to determine what kind of SPDs is necessary where in the system. What is good from GoodWe is that our inverter all includes some type of SPD. In our C&I segment and utility segment, usually the standard SPD on both on the DC and AC side is the SPD type 2. This already gives a quite good protection to the system and also reduce the overall installation costs. For the HT series, we also have the option for type 1 SPD on both the DC and the AC side, and we also have a type 3 SPD on the communication board to protect that and all communication devices connected to the inverter. Now, shortly about the protection of the data. So the data is usually sent between the GoodWe inverters up to a server and then further to either our portal or to some third-party portal. This data can be quite sensitive, so it's important that it's secure and no one else can reach it. and therefore it's encrypted both when it's being sent from your PV system to our server, but also when it sends between our server to the portal. However, when you, as some of you may know, when you install a GoodWe inverter, you need to commission it by accessing the inverter through some Wi-Fi or communication module. And then usually there is a default password at the beginning, and this we do recommend to change to really keep your data secure. Moreover, there is also a second way to protect your data. So let's say now that you don't install the correct SPDs and there's a lightning strike in the nearby of your installation, causing a power surge to destroy basically your inverters and your modules, and your whole installation is down. However, it is not always easy to know the cause, but in this case, our GoodWe inverters, so for example, for the HT series, if they're connected to the internet, you can of course track that there, but even if they're not connected to any server, it's possible to access the damaged inverter with a USB stick and retrieve the last couple of data before and after the accident to analyze and see what could have caused it. And now for some case references. So here are some CNI projects that we have in both Turkey and the Netherlands. So here you can see both the HT inverter as well as the MT and the SMT. And here is also a 40 megawatt plant in China. So today you, Jonas, first talked about how you can protect your system from fire. I also explained how you can protect it from power surges and how to protect your data. And Jonas also mentioned some specific requirements for Germany. Lastly, I just want to give a shout out for our GoodWe Solar community. This is where this webinar is hosted, or is being held right now. But if you haven't checked out all the different functions, I sincerely recommend you to do it. This was launched the 1st of July and is sort of trying to be a knowledge sharing platform, not only for our GoodWe inverters and GoodWe products, but also for the PV market and other general topics. So there we have several different webinars. We also have different videos on how to install and commission the inverters. We also have different articles on different topics of functions, not only for the GoodWe inverter, but general topics that's essential for the PV industry. So please free to join that, and in case you haven't already, you can join it with your email address, or you can also use your SEMS login to join it. Being active on the community, you also collect different points, and that you then can redeem for different prizes. So thank you for listening to this webinar, and make sure to look at our GoodWe website in the future and our GoodWe Solar community to find other webinars and videos. Thank you.